rapid increases in greenhouse gases in the last several decades. And we also have models which help us to interpret those observations. But nevertheless, you can ask the question, why should we be concerned about human-made climate change? Because we know that in the Earth's history there have been huge changes of the Earth's climate. And these questions can be asked by well-educated people. In fact, this is word for word which was said on National Public Radio by my boss's boss's boss, the NASA administrator. We can, however, answer these kind of questions. I think it is useful to look at long time periods when climate was very different. This is the temperature of the deep ocean over the last 65 million years. Today is on the far right, and the temperature in the deep ocean is about 0 degrees Celsius. But 50 million years ago, it was 12 degrees, 13 degrees Celsius. The planet was so warm at that time that there were alligators in Alaska. There was no ice on the planet. No ice sheet on Greenland was covered by forests, and Antarctica had no ice on it. And but the planet, beginning 50 million years ago, cooled off. Until 34 million years ago, it was cool enough that ice began to form on Antarctica, and it glaciated quite rapidly. And then, since then, the planet has gotten still cooler. Now, we know the primary reason for that. The planet's temperature can be changed either by the amount of energy coming in changing, or from some changes within the atmosphere, or from some changes on the surface of the planet. But we know that our sun is a well-behaved main sequence star, which means it's still in the phase of burning hydrogen. It's nuclear fusion in the core of the sun is combining hydrogen to make helium and releasing energy. And the sun is slowly getting brighter over time. 65 million years ago, it was 0.4% dimmer than it is now. And because the Earth absorbs about 240 watts of energy from the sun, averaged over the surface, 0.4% means that the amount of energy absorbed by the planet has increased by 1 watt per meter squared, one of those tiny bulbs that Connor was holding up. Changes on the surface can also have an effect. The continents 65 million years ago were already close to their present locations, in terms of latitude. And so the change in the amount of sunlight absorbed due to where the continents are is less than 1 watt per meter squared. But the other thing, the atmosphere, we know that 50 million years ago there was more than 1,000 ppm of CO2 in the atmosphere. During the ice ages, the coldest times, there was only 170 parts per million. Today there's 389. That change from 170 to 1,000 is a forcing of more than 10 watts per meter squared. So the dominant reason for those large changes in climate is due to the atmospheric CO2. And we know the main reason that happened. It's because the amount of CO2 in the atmosphere naturally, before humans started to burn fossil fuels, the amount of CO2 is determined by the balance between the source of CO2, which is volcanoes, and the sink for atmospheric CO2, which is the weathering process. As the rivers carry sediments to the ocean, the chemical reactions associated with that weathering end up depositing carbonates on the ocean floor and drawing CO2 out of the atmosphere. But those two processes, the source and the sink, are not necessarily in balance at any given time. It depends upon how many volcanoes you're getting, and that depends upon continental drift. Volcanoes occur where continents move and subduct beneath them ocean floor. And as this high pressure and temperature of the continents riding over the ocean floor causes the metamorphosis of the ocean floor, the carbonates, into other rocks, and it releases CO2 that comes out in the volcanoes. And when India, and the one thing that was different 65 million years ago is India was still south of the equator. India was moving north at a rapid rate of about 20 centimeters every year, which is, for continental drift, is quite fast. And it was moving through an ocean that had long been the depot center for the major rivers of the world. So that ocean floor was carbonate rich. And as India rode over that ocean floor, the CO2 was released to the atmosphere, and the planet got warmer and warmer until India crashed into Asia and began to push up the Himalaya mountains and the Tibetan plateau. And then that reduced the source of CO2, the volcanoes, and it increased the sink because the weathering of these rocks in the Himalayas draws CO2 out of the atmosphere. So CO2 decreased and the planet cooled off over that time period. And those are huge climate changes. As I said, there were alligators in Alaska in that red part of the curve. The rate at which volcanoes put CO2 into the atmosphere is only of the order of 1/10,000th of a part per million of CO2 per year. And over a million years, that's 100 ppm of CO2, which is a huge change, and that can cause large climate changes. But look at the rate at which humans are changing CO2. We're increasing it 2 ppm per year. So we're changing things 10,000 times more faster than the natural process can change it. So humans are now in charge of future climate change. It would, of course, the administrator was right. You can have large changes, but those are on much longer time scales. And humans have, entire civilization developed during this current interglacial period called the Holocene, which has had relatively stable climate for the last 12,000 years. And now the future climate is going to be determined by humans, not by natural changes. And the other thing is that how much CO2 was there at the time that Antarctica began to freeze over? We estimate from this study that it was about 450 parts per million. Some other different studies have got somewhat higher numbers, but the basic point is that if we burn all the fossil fuels, we'll increase CO2 to much more than that. We would be heading the planet back toward the ice-free state. We can't say exactly how long it would take to get there, how long it would take for the ice sheets to melt, but there's no doubt that we would be producing a different planet, very different than the one that civilization has developed on. And another thing that we can do, besides looking at the Earth's history, is to look at